We're going to go through the notes for Chapter 9, Quadratic Equations, starting with Chapter 9.1, which is the square root property. And completing the square. So we just need to, we're going to be looking at quadratic equations. Remember that the standard form for a quadratic equation has a power of 2, is ax squared plus bx plus c equals 0. A, b, and c are real. And a does not equal 0, otherwise we lose this and it would be a linear equation, not a quadratic equation. And that is the standard form for a quadratic equation. We already took a look of how to solve these when you can factor. And what we did is we used the 0, this is a recall, the 0 factor property, which said that if you have two items, a times b, and that equals 0, then, that's if, a times b equals 0, then a equals 0 or b equals 0. Otherwise, when you multiply them together, there's no way you're going to get 0. So one of the, well, you go back to chapter, I think it was 6 to take a look at that, but I can do one quick for you here. Let's just say 3x squared minus 5x minus 28 equals 0. You'll do 3 times negative 28 and find the factors of that. You end up with negative 84. That's a negative number, so then they have to be positive and negative, and then when I add them, I'll get a difference of 5, the larger being negative. So I'll take a look at that. So I start from the top, 1 and 84, 2 and 42, 3 and 28. I'm looking for differences. They're still too big. 4. Yep, 4 and 21. Not a 5. 6. 84 divided by 6. So what I just did was 84 divided by 6 to see if it was a factor, and it was. So I'll go 6 and 14. That difference is 8. I'm not there yet. 7, 84 divided by 7, that works. So 7 and 12, there's my difference of 5. 8, no, 9. 84 divided by 9, nope. 10, 11, 12. Okay, that just happens to be the last one. So I know that the numbers, so I want a negative 5. These have to be different signs, so this is going to be a negative 12 and a positive 7. So I'm going to expand the middle term. 3x squared minus 12x plus 7x minus 28 equals 0. I decided to do the 12 first because I saw that there's a 3 in the front and I know they both have a 3. So now I factor by grouping. And I see that the first two terms have a 3x in common. And I write down what's left, which is x minus 4. And the second two terms have a positive 7 in common. And I write down what's left, x minus 4 equals 0. Now these two terms, first term, second term, have a factor of x minus 4 in common. So I'm going to pull it out and write down what's left. That gives me the factored form. Then I'm still trying to solve, so I'm going to utilize a times b equals 0. So if this times that equals 0, then 3x plus 7 equals 0, or x minus 4 equals 0. This one's a little bit easier, but negative 7, 3x equals negative 7, so x equals negative 7/3, and this one add 4, x equals positive 4. So of course they need to be checked, but for now we'll say that the solutions, and they do check, are negative 7/3 and positive 4. That's the only way we were able to solve these quadratic forms. But we have other ways. It depends what you're given. We've got the square root property. The square root property. So if x squared is equal to a number, for example, x squared equals 25, we've seen it. We need to solve for x. Well, we've already kind of looked at this. We know that x can equal positive 5, or x can equal negative 5. Whoops, negative 5. When I take negative 5 and square it, it becomes positive 25. When I take positive 5 and square it, it becomes positive 25 as well. So I could do the same thing here. How did I get from 25 to 5? I took the square root. So I can actually take the square root of both sides. The only thing you have to worry about is if you take the square root of a square, you have to include both the positive root and the negative root. So this becomes x equals plus or minus square root of k, which means that x equals negative square root of k, or x equals positive square root of k. You can write them in either order. But there's actually two answers. So this is two solutions. Just like we had two solutions for this example over here. We had positive 5 and negative 5. Well, when we have some x squared, we are looking for two solutions, or at most two solutions. Let's do an example for this. Oh, nothing too simple. Well, how about this one? Well, let's say m squared equals 64. And let's say p squared equals 7. So find the values of m that make this equation true. If I take the square root of both sides, I'm just trying not to do that, m equals the square root, oops, when I do that I need a plus minus. So it's plus or minus 8. Two solutions, plus 8 or negative 8. This one does the same thing, square root of p squared plus minus square root of 7. So p equals plus minus square root of 7. And I'm going to check this one. So if I say negative square root of 7 squared, what does that equal? Well, when I square a negative number, I get a positive number. And the square root of 7 times the square root of 7 is just 7. So yep, that checks. That's what's going on with that. Now remember, the square root property always produces two answers. Or when you take the square root of a square, because we're trying to undo it, don't forget the plus minus, or plus minus. Okay, good. So let's look at something that's a little bit more complicated. Let's try this. 4x squared minus 28 equals 0. So you can probably go ahead and try to factor. Oh, well, we can. Let's go ahead. We could pull out a 4, and we get x squared minus 7 equals 0. How would I solve that? Well, let's set each factor equal to 0. Well, can you factor this? No. So since we've only got an x squared in here, not an x term, makes things a little bit easier. We can actually divide both sides by 4, and lo and behold, this 4 cancels, and the right-hand side is still 0. So I said I wanted to use the the square root property. I could have moved the 28. Now I'll just move the 7 over to the other side, and it kind of looks like this problem that we have up here. And we take the square root of both sides, plus minus square root of 7. So we get x equals plus minus square root of 7. Let's see. Okay, so we want what's the point of this? Because we can also handle these. X minus 3 squared equals 16. Ooh, sorry. We can also handle those. X minus 3 squared equals 16. Easily. I don't have to square this all out and then move the 16 over and then try to factor and see what's going on. You could, but if you notice, this side is squared. At this point, I can undo that square to just get an x minus 3. So let's try that. Square root of x minus 3 squared equals plus minus square root of 16. Okay, that's 4, so that's kind of nice. What do you get on the left-hand side? Well, the square root of a square undoes it. You're not worrying about that part being positive and negative. You're fixing it on this side. So at this point, this is 2 answers. X minus 3 equals positive 4, and x minus 3 equals negative 4. So you'll add 3 to both sides. This one becomes x equals 7. You'll add 3 to both sides. This one becomes x equals negative 1. You're going to need to get familiar as to when to split this. Whenever you're adding or subtracting, don't try to do it in one step. Add 3. You're going to get lost. So the solution for this one, well, let's check. I want to first check x equals 7. Okay, so I got 7 minus 3 squared. Does that equal 16? That's 4 squared equals 16. That one's good. The next one, negative 1 minus 3 squared. Does that equal 16? Negative 4 squared. Does that equal 16? Yes, 16 equals 16. That one's also good. So they're both good. The solution to this is negative 1 and 7. I should have blocked that one first. Okay, moving on. Now, see when they're in this form or close to that form, go ahead and use the square root property. Don't try to make it more complicated than what it is. As a matter of fact, if I did factor, if I did multiply these or square this binomial, and do the double distribution and then bring over the 16, it would have factored. I would have been able to factor it. So completing the square is getting it in this form. So that boom, 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 you're done. It's easy. So let's take a look at that. You know what? One more. And I'm going to write it down, and you guys can take it from there. Give yourself a few minutes to solve it. And I will do this one on your own. 2r plus 3 squared equals 8. So stop the video there and try that on your own. Okay, welcome back. Here we have radical 8, so we should probably try to factor that. And radical 8 equals radical 2 times 2 times 2, which is 2 radical 2. So next time I'm going to write that down. I get 2r plus 3 equals positive negative 2 radical 2. I subtracted 3 from both sides. Those are not like terms. 2r equals negative 3 plus or minus 2 radical 2. This might start looking familiar to you. I need to divide this entire side by 2. The entire side by 2. Or you can divide each term by 2. So we've got r equals negative 3 over 2 plus minus, this reduces to radical 2. There's your solution. That's actually 2. It's 2 solutions. 2 solutions. You've got r equals negative 3 halves plus radical 2. And, whoops, how about we do this? We'll put it in set notation. Negative 3 halves minus radical 2. Now, what answers are those? What is that number? Well, you can actually negative 3 halves plus radical 2. This one is about negative 0.858. We'll keep it like that, 858. I forgot the 0. No, let's start over. Negative 0.0858 for place values, and negative 3 halves minus radical 2. We get negative 2.9142. So that's approximately. So they're just numbers. You just can't combine them. This is an approximation because I'm approximating radical 2. Now let's talk about solving equations by complete. Let's talk about getting them in this form so then we can solve it this way. So we're going to talk about completing the square. Complete the square. You have okay, recall. If we have something that looks like this, x squared plus 10x plus 25, and we want to factor this, we end up with two numbers that multiply to 25 and add to 10. I'm going to go the shortcut method. It ends up x plus 5 times x plus 5. But that is just x plus 5 squared. That is the form that we were working with before, on the left-hand side anyway. So a lot of times you get an x squared, an x squared term, an x term, and a constant term. But remember, if we have an equation, we can do, so this number 5 is pretty special. This number 5 here, the term in the middle is twice that. That's 2 times 5. And the term here on the end is 5 squared. So if I could figure out this number from possibly these two terms, I can add what I need here to make this a perfect square trinomial. So I guess I'm saying this. Note, let's say we have something that looks like x plus a squared equals x plus a times x plus a, and when you multiply, you end up with x squared plus 2a plus a squared. So note that the number here is plus a, and this is 2 times that. Also, if you have x minus a, with this a being positive, I'm just showing you that you end up with the same thing if you have a negative number in the middle. You still end up with x squared minus 2a, so it's still double what this is. This is positive a, this is negative a, and that's, this middle term is double it. I forgot something. I forgot an x here. Got the x, because it's ax plus ax equals 2ax. This has an x on it, plus, oh, yep, negative a times negative a is positive a squared. So they've got the same type of form. So if we start with something that looks like this, x squared plus 8x plus 10 equals 0. This is not a perfect, whoops, this should be 0. This is not a perfect square, but I can get rid of this 10 on both sides. Then I end up with x squared plus 8x on the left-hand side. I can add a constant so that this is a perfect square to both sides. So I'm adding a constant to both sides. Now, these are going to be exactly the same number. Exactly the same number. But what number am I adding? What I need to do, this b term right here, maybe I should have called it, no, this is the b term. B value. It's the coefficient of x. I'm also pointing out here that the coefficient, the a value, is going to equal 1 for this case. We'll be able to handle it when it doesn't equal 1. But for now, let's see what's going on. Okay, so the b value. How did we get, so before we had a 10, and we ended up using a 5. So there's a factor of 2. So I take that b value, I multiply it by 1/2. That's going to be the number in the bubble. But the constant, I'm going to square it. And that's the number that's going here. So for hours, 1/2 times 8 squared, which is 4 squared, which is 16. So I actually need to add, just trying to get another color, I need to add 16 to both sides. So if I add 16 to the left and add 16 to the right, I've kept the equation in balance, right? I've kept the equation in balance. Here is the information you're going to need. Takes some getting used to, but don't get rid of your steps, because this number is important also. When we are, so I'm just going to rewrite this. X squared, let's be black, x squared plus 8x plus 16 equals negative 10 plus 16. This is a perfect square. Find two numbers that multiply to 16 and add to 8. Those two numbers are 4 and 4. Keep in mind that that's just x plus 4 squared. You can go right to this step and avoid the intermediate step. Just make sure you know what you're doing. And bringing this down here, I just get 6. Voila. The equation to this, the solution to this will be the same as the solution to the original. The only thing I've done is just add 16 to both sides. I've kept it in balance. So solve. Take the square root of both sides, plus minus x plus 4 equals plus minus square root of 6. Subtract 4, x equals negative 4 minus radical 6, and negative 4 plus radical 6. Those are your two solutions. You can trust me or you can check it. I'm going to check it. I'm going to check. Let's check x equals negative 4 minus radical 6. And my equation was x squared plus 8x plus 10 equals 0. So, negative 4 minus radical 6 squared. So I'm going to actually have two of those because I know I'm going to have to separate it anyway. Oh, this is new for me. 8 negative 4 minus radical 6 plus 10 equals 0. So this is x squared plus 8x. This one is 16 plus 4 radical 6 plus 4 radical 6 plus just 6 plus, oh, that should be a negative, minus 32 minus 8 radical 6 plus 10 equals 0. Woo, okay. 16 plus 6 minus 32 plus 10. I am not even going to trust myself with that. I'm going to move it all the way up, that way you could see the screen. Okay, so we got 16 plus 6 minus 32 plus 10. 0. Good. Constant's is 0. Then I've got 4 radical 6 plus 4 radical 6 is 8 radical 6. And this is the only term that's left. Minus 8 radical 6. 0 equals 0. Great. Now let's just take a look as if we kind of did the plus piece here. This would be a positive, this would be a positive, and this would be a positive, right? When we distributed, this would be a negative, this would be a negative, this would still be a plus 6. This would still be negative 32, but this one would be a plus 8 radical 6. So the constants didn't change, but the radical 6 terms, this is negative 8 radical 6, and this is positive 8 radical 6. So it would have checked with negative 4 plus radical 6 as well. Isn't that neat? I think that's dandy. Okay, so let's do another one. So complete the square. Completing the square takes some practice. Let's do, I'm trying to find something. Let's do x squared plus 2x minus 10 equals 0. Find two numbers that multiply to negative 10. I was just going to say 5 and 3, but no, 5 and 2, which is a difference of 3, that have a difference of 2. There's nothing. There's absolutely nothing. So let's complete the square. Get this out of the way. Get the positive 10 out of the way. All we want over here is a blank so that we can complete the square on the left-hand side and the right-hand side will just flow. So let's move this over here. X squared plus 2x. I'm going to include a blank equals, when this moves over here, it becomes positive, but the same plus blank. So when we do this, we take the b term, b, 1/2 of b squared. That's our constant. Is 1/2 of b squared. 1/2 of b, quantity squared. So this is 2. b is 2. 1/2 of 2. 1/2 of 2 is 1. Don't forget that. So as I run through this, that 1 is kind of important too. I just need to add a 1 here. 1 to the right, 1 to the left, 1 to the right. Then when I actually factor two numbers that multiply to 1 and add to 2 would be 1 and 1. Positive 1 and positive 1. I missed that step in the middle. And the right-hand side is going to be 11. You have some getting used to. Take the square root of both sides, because, I mean, that was our point to solve this. Right? Take the square root of both sides. The left-hand side, I'll just go like this. Plus minus x plus 1 equals positive and negative radical 11. I can't simplify radical 11. So just subtract 1 from both sides, and x equals negative 1 plus minus radical 11. There's your two solutions. So steps. They are on page 550 in the textbook. Ooh, I didn't give you one that didn't have a leading 0. Well, you know what? I'm sorry, a leading 1. Okay, 1. Let's say we're going to start with ax squared plus bx plus c equals 0. Standard form. The first thing you need to do is get this as a leading 1. So the first thing you're going to do is divide, divide all terms by a. Some will be nice, some won't be nice. 2. Move the constant to the 0 side. This was called the non-zero side. That's, I guess, the 0 side. It's not 0 anymore then. Move the constant to the 0 side. We're going to subtract it off. We're going to add the opposite to both sides. You can just pick it up and throw it over there. Add the opposite to both sides. Okay, and then what did we do? Let's think here for a second. We added a constant to both sides. Add the constant. Add the constant. if I divided them all by a, that's okay. Add the constant. Half the square of half the coefficient of x. Now I'm assuming that the variable is x. Half square of add the constant. Add the constant, the square of half. So, you know, when we actually divided by a, we ended up with x squared plus b over a x plus c over a equals 0. When we moved the constant to the other side, making these very small because you don't need to memorize this, ba over x equals negative c over a, right? Because I said move the constant to the 0 side, and that was the constant c over a. I added the opposite to both sides. So here, half the coefficient of x is actually, this ends up being b over 2a squared. And that is our constant. We'll use this later when we talk about the quadratic formula, because that's what it's doing. That's how it was derived. Keeps your a's and b's and c's all together. Add the constant to both sides, and then what did we do? We actually factored the perfect square trinomial. 4. Factor the perfect square trinomial. Factor the perfect square trinomial. And then 5. Solve using the square root property. Five steps. Always so many steps, right? It's easy to get lost in this process. So that's why I wanted to make sure I wrote them all out. And you just keep going and going and going. I want to give you a harder one that where a does not equal 0, and work through that one. So let's try, I'm going to try something that's not that nice. At least if I try it with you, we're okay. So let's try this. Solve 2r squared minus 4r plus 1 equals 0. Step 1 was divide all the terms by a. So everybody gets divided by a. A is this 2. So what I end up with is r squared minus 2r plus 1/2. 0 over 2 is still 0. Then I move the constant to the other side and create a space so I can do some work. R squared minus 2r plus a blank equals, now moving this over, negative 2 plus the same blank. What's going in the blank? This term here is negative 2. I take half of it and then I square it. This in here becomes negative 1 squared, which is 1. So all I'm doing is adding a 1 and then complete the square. I complete the square on this side. Let's just double check or make sure. Move the constant to the 0 side. Add the constant, square of half the coefficient of x. I took the coefficient of x, in my case was negative 2. I took half of it, or divided by 2, and then squared it. It ends up, this negative 1 is your magic number. Oops, not x. R minus 1 squared equals, now I got to take care of this, negative 1/2 plus 1/2 is a 2 over 2. 2 minus 1 is 1 over 2. Take the square root of both sides. Square root of r minus 1 squared plus minus square root of 1/2. R minus 1 equals plus minus square root of 1/2. I'm looking at that and I'm noticing it's not rationalized. So I'm going to take a look at square root of 1 over 2, which is square root of 1 over square root of 2. Well, square root of 1 is just 1, but this is where the problem is. I need to rationalize the denominator. So I'm going to multiply the numerator and the denominator by square root of 2. My top becomes square root of 2. My bottom becomes just 2. Believe it or not, that's simplified form. So what do I have? I have, and I'm going to add 1 to both sides. So let's see what's going on. R equals 1 plus minus radical 2 over 2. So instead of square root of 1/2, I'm writing it as radical 2 over 2. That's your answer. Two answers. Two answers. The two answers are, I can also get this as a common denominator of 2. 2 minus radical 2 over 2. I cannot simplify that any further. Well, I can, but it's going to look like this, which isn't going to help me. And 2 plus radical 2 over 2. That's it. So do the 9.1 homework. And I will see you for the video in 9.2.